Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 1 paper from autumn 2023. This paper is worth 120 marks in total, and this is the fifth video of 6. It will focus on questions 21 to 24, which account for 19 of these marks. Eduqas Component 1 papers are non-calculator papers, so a calculator should not be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 21. Alice is investigating how much time, in minutes, pupils at her school spend on their mobile phones. She asks 100 students in Year 11 and 100 students in Year 7 to record how much time they each spend on their mobile phones on a Monday. Part A. The results for Year 11 are shown in the table below. So we've got the information that she's gathered there. Alice displays her results in the histogram below. So we've got frequency, density, time, and then we've got our histogram bars. The question says to give one criticism of Alice's histogram. Okay, so let's just compare the data to the histogram to start off with, because that's what we would have drawn it from. So we've got 0 to 50. So if we go down here, 0 to 50 would be here, but she's gone 0 to 100. So what it looks like she's done is grouped this together for the histogram. And then we've got 100 to 200, which matches here. 200 to 300, which matches here. But then again, we've gone 300 to 500, so she's grouped these. Now, by grouping that data, she will have lost some information, okay? Because these are all estimating with the range of values. So I'm going to just put there, by grouping data, she has lost some information, because separate bars would have potentially shown a different trend in that histogram. Also, if then we were trying to find the modal class, that's potentially going to have changed if we now only have 4 classes compared to starting with 6. So by grouping data, she's lost some information. Part B. Alice's histogram showing the results for the 100 Year 7 students is shown below. The group with the time 200 to 300 is missing, so this bar here. We've got our histogram. They want us to complete the histogram, and we must show all of our working out. Okay, so to work out the histogram, we would have done the frequency divided by the class width, and that would calculate the frequency density for us. So to reverse that and find out how many students, we're simply going to find the area of those bars. So instead of doing the frequency divided by the class width, we're doing the class width multiplied by the frequency density. So let's call this A, B, C, D, and E. Okay, so the area of A, so we're from 0 to 100, so it's 100 multiplied by 0.1, 1, 2, 3, 4, 5, 6, 7, 8. Which is 18. Let's work out bar B. So from 100 to 150, so that's 50 multiplied by 0.4. Well, 0.4 times 10 is 4, and then times by 5 is 20. Same for the bar C. Across is 50, and then up is 0.2. 10 times 0.2 is 2, times by 5 is 10. Let's do the same for D. 300 to 400 is 100, multiplied by 0.1112, which is 12. E equals 400 to 500, which is 100, multiplied by 0.1, which is 10. Okay, so we have 100 students in total. So let's see what these total up to, so we know how many students to include in that 200 to 300 bar. So 18 plus 20 plus 10 plus 12 plus 10, so that's 38, 48, 60, 70. So we've got 70 of the 100. So 100 take away 70 tells us that there's 30 students that need including in this bar. But we need to work out the frequency density. So we do the frequency divided by the class width. Well, the class width is 200 to 300. So 30 divided by 100 is 0.3. So our bar's going to go up to 0.3. Now I'm using a pen here, guys, just so you can see it nice and clearly. But I highly recommend you use a pencil in your exam, just in case you need to rub it out so that things don't get confusing for the examiner. So there we are, we've completed the histogram. Part C, make one comparison. So one comparison between the amount of time spent on their mobile phones by all the students in year 11 and all the students in year 7. Okay, so what we're not going to do with this question is compare the histograms. One, because that's not correctly filled out, the data was grouped. But two, we can spot trends, but that's just about it. It doesn't tell us really anything. So we're going to work with the numbers here, guys. Okay, so I'm going to fold this over so we can see it at the same time. So we're going to work with the numbers. So I'm going to compare, so let's go, for example, up to 200. So from 0 to 200 for year 11s, 3 plus 5 plus 20 is 28 pupils. From 0 to 200 for year 7s, well, that's A, B and C. 18 plus 20 is 38, plus 10 is 48. Okay, so more students, more year 7 students spent 200 or less minutes on their phones than year 11s. So that's the comparison I'm going to give them. So I just compared the first few points of data to write a statement. So I'm going to say more year 7 students spent 200 minutes or less on their phones than year 11. Question 22. The following iterative formula can be used to find the number of cells of bacteria after n days. So we've got a starting value of 1000 at day 0, and then to find the next day, we use the previous value in this iterative formula. Part A, show that the number of cells of bacteria after 1 day is 1200. So this is when n equals 1. So we need to start with B0. Day 0 is 1000. But then day 1 would be this iterative formula using that previous value. So it would be 1.2 multiplied by 1000, which is equal to 1200. Part B, use this formula to find the number of cells of bacteria after 3 days. So this is after 1 day. So we're going to use this formula again. So it's 1.2 multiplied by the previous value, so 1.2 multiplied by 1200. So I'm going to times this by 10, so we're doing 12 times 1200. Remember, you can use any multiplication method you wish. 2 times 0, 2 times 0, 2 times 2, 2 times 1. 0 placeholder, moving into the tens. 1 times 0, 1 times 0, 1 times 2, 1 times 1. Let's add these together. So that's 14,400. We need to reverse this process. We multiply by 10, we need to divide by 10. So that's 1,440. That's day 2. We need day 3. So it's going to be 1.2 multiplied by the previous value. Okay, so let's multiply this by 10. 12 multiplied by 1,440. So 1,440 multiplied by 12. 2 times 0, 2 times 4, 2 times 4, 2 times 1. Placeholder 0 moving into the tens. 1 times 0, 1 times 4, 1 times 4 and 1 times 1. Add those together, so 0, 8, 12, 7, 1. Reverse the multiplying by 10, so we're going to divide by 10, so that's 1,728. So after 3 days, it's 1,728 cells of bacteria. Question 23. Adina has 5 wooden blocks. Each block has a different colour: blue, red, green, yellow and purple. Adina selects 3 of these wooden blocks at random. Each time she does this, she places them on top of each other. 2 ways of arranging the blocks are shown. So she picks red, then yellow, then blue, purple, then red, then green. Part A, calculate the number of different ways of arranging the blocks. So different ways that those 3 blocks she chooses can be arranged. Okay, so this is combinations, combinatrix, guys. So when she picks the first block, she has 5 blocks to choose from. So we're going to have 5 blocks available there. When she picks the second block, she will only have 4 blocks available. And then when she picks the third block, she will only have 3 of them available to pick from. So 5 times 3 is 20 and 20 times 3 is 60. So there are 60 different ways that those blocks can be arranged. Part B, how many arrangements are there where the middle block is either blue or red? Okay, so when she picks the first block, it's only going to, the middle block's going to be blue or red. So that reduces our options by 1. Okay, because if it was red, we'd still have blue to pick from. But if it was blue, we'd still have red to pick from. So on the first pick, we've got potentially 4 colours to pick from. On the second pick, so the middle block, we've only got 2 options, blue or red, haven't we? And then on the third pick, we're going to multiply by 3 because we would have 3 potential colours to pick from. Because we've already picked 2, there's 3 left to pick from. Okay, so 4 times 2 is 8, 8 times 3 is 24. So there are 24 arrangements where the middle block is either blue or red. Question 24. The velocity time graph below shows the velocity of a car for the first 20 seconds from rest. So we have velocity and time. Part A, calculate an estimate for the acceleration of the car at time 8 seconds. So we need to draw a tangent to the circle at 8 seconds, guys. So 8 seconds would meet the curve here. So we're going to draw a tangent. So when we draw this tangent, we're not going to cut through the curve. We're just going to touch it slightly, but we want it to follow the same trend of the data of the actual curve itself. I've done it in pen so you can see it nice and clearly. It's a good idea for you guys to do it in pencil so that you can rub it out if you need to reposition your tangent at any point. Okay, then that's your first mark for drawing a tangent at 8 seconds. The next, we're going to find the gradient of that tangent. So the change in y divided by the change in x. So we're going to pick 2 points on this tangent line. I'm going to go with this point here, which is at 0, 10. And then I'm going to go with the point there at 8. And then I'm going to read across from there. So that's 21, 2, 3, 4. So that coordinate point is 8, 24. So the change in y from 10 to 24 is 14. The change in x from 0 to 8 is 8. We can simplify this a little bit further, and you could write it as a mixed number if you want to. And then I'm going to leave it there. That's my estimate for the acceleration at 8 seconds. All right, you might get a slightly different answer to me if you've drawn your tangent slightly differently, but as long as you draw a reasonable tangent, you work out the gradient of that tangent, you're going to get the marks for this question. Part B. Use 5 vertical strips of equal width to calculate an estimate of the distance travelled by the car during the first 20 seconds of motion. So we are going to use our velocity time graph, and we're going to split the area underneath the curve into 5 strips of equal width. And quite handily, we have 5 strips of equal width here. So we're going to draw those strips in to split them up. So I'm just drawing the vertical points at the moment. But then it's an estimate, so I'm now going to form shapes, polygons underneath. So here I've formed a triangle. There I've formed a trapezium, a trapezium, a trapezium, and then obviously the other one is a rectangle. So let's call that A, B, C, D and E. And I'm just going to fold this so that we can use the graph on the other page as well to do some working out. So we're going to work out the area of A first. A is a triangle, so we're going to do the base, multiply by the height, and then half it, guys. Okay, so that's 15. Is it 15? Oh no. Let's just double check over there. So that's the top of the triangle where it meets the curve. Actually, that's 16, guys, isn't it? So we're going to do 4 times 16. So for the area of A, 4 times 16 is 64. But then we need to half it. So 64 divided by 2 is 32. So that's our first distance total for B. So B is a trapezium, so we've got a height of 16. We need to figure out this other height, so where it meets the curve. So that's a height of 24. So you add the parallel sides together for a trapezium. So we're doing 16 plus 24, which is 40. We multiply by the space between them, so that's 4. 40 multiplied by 4 is 160, and then we half it. So 160 divided by 2 is 80. So that's our other distance total there. We're going to do the same for C. So on C, we know that this is 24. We need to read off accurately as much as possible this value. So it's 25, 26, 27, 28. So that's 28, and then this other side is all the way up to 30. Okay, so for C, we have got 24 and 28. So 24 plus 28 equals 40, 52. We're going to multiply that by the distance between them. So 52 multiplied by 4 is 208. And then we're going to half it. So 208 divided by 2 is 104. So that's our third distance calculation. Now we're going to work with D. Okay, so this side is 28. This side is 30. So 28 plus 30 equals 58. Multiply by the distance between them, which is 4. 58 multiplied by 4 is 232, and then we're going to half that because it's a trapezium, which is 116. So that is our fourth distance measurement. Okay, the last one is E. So E is a rectangle, so we've got a length of 30 and a width of 4. So we're going to do 30 multiplied by 4 is 120. So then now we've got all of our estimates for distances for each strip underneath the curve. We're going to add them together. So 32 plus 80 plus 104 plus 116 plus 120. So that is 112. That is 220. So 112 plus 220 is 332. 332 plus 120 is 452. So we're estimating it's 452 metres travelled.